Hi, I'm Robert Crowe. You know that debugging is crucial when doing any kind of software development. JAX and Flax NNX offer amazing performance and a clean API, but debugging can feel different due to JAX's compilation model. Today we'll bridge the gap, exploring how to debug JAX and NNX effectively, relating techniques back to your PyTorch experience. We'll focus specifically on the Flax NNX API. In this final episode of our three-part series on debugging, we'll expand beyond JAX-specific tools to the broader ecosystem, focusing on building robust, monitorable, and performant code. Finally, we'll bring together all the concepts into a practical, step-by-step debugging workflow. In the previous episode of this three-part series on debugging, we went beyond the basics, learning how to use the JAX.disableJIT escape hatch to bring in standard Python tools. We also covered how to automatically find the source of nans and dove deep into Flax NNX's powerful inspection capabilities using NNX display to understand our model's architecture and NNX SO to capture internal activations. Now we're putting it all together. We'll start by reviewing how to make our code more reliable from the ground up with the checks library. And then we'll explore the essential ecosystem tools for monitoring, profiling, and visualization. Let's start by reviewing how checks helps us avoid problems before they become bugs. If you haven't already watched the series on checks, there is separate videos in the playlist. To make your JAX code more robust and catch errors early, use the checks library. We discussed checks at length in that other video, so if you haven't seen that one, check out the playlist on YouTube. Checks offers many assertion functions specifically designed for JAX arrays and structures, which are PyTrees. Let's start with static assertions. These check things like shape, rank, which is the number of dimensions, and data type. Because these properties are known during JAX's tracing phase, you can put these assertions directly inside your JIT-compiled functions, and they just work, providing valuable checks without needing runtime values. Here's some examples of the kinds of assertions which are available in checks. TensorBoard is another great tool for debugging and profiling. Just like in PyTorch, TensorBoard is invaluable for visualizing training progress in JAX. Setting it up is straightforward. First, make sure TensorBoard is installed. Then, in your Python script, you need to create a summary writer. Interestingly, the most common way to do this in the JAX ecosystem is by using the writer utilities from either TensorFlow or PyTorch itself. But you can also use TensorBoard X. All of these writers save logging data to a specified directory. Finally, you launch the TensorBoard server from your command line, pointing it at that log directory, and you view it in your browser, usually at port 6006. Here's the basic code for creating a TensorBoard summary writer. TensorBoard X is a nice option for this because it's a much smaller import. Inside your training loop, you use the writer object to log data. For logging metrics like loss or accuracy, use addScaler. The key thing to remember, coming from PyTorch, is that you need to convert the JAX array, even if it's zero-dimensional, to a standard Python number using .item before passing it to the writer. You can also log images, text, and histograms. The API is similar to how you'd use it in PyTorch or TensorFlow. JAX also has profiling tools that can integrate with TensorBoard to help diagnose performance bottlenecks. Here's some example code for logging scalars, in this case with a PyTorch writer. In this screenshot from the tutorial, which is linked in the code exercise, we show the XProf profiler running in TensorBoard. Let's review and highlight the similarities and key differences and ways to adapt your PyTorch experience to JAX debugging. Let's quickly map the concepts. Your familiar PyTorch tools have direct or close counterparts in the JAX world. Standard print and PDB can be used if you disable JIT, or if you're running in functions that don't use JIT. Inside JIT, you use JAX.debug.print and JAX.debug.breakpoint. For checking nans, checks assertions are a robust option. Instead of printing the model, you use NNX.display. TensorBoard usage is very similar. Checks provides a powerful assertion library. While there are similarities, key differences do require adaptation. The impact of JIT is paramount. You constantly trade off between using specialized JAX tools within JIT or disabling JIT for standard tools but losing speed. PyTorch's hook system doesn't have a direct equivalent. JAX encourages more functional approaches like returning intermediate values or transforming functions. The way state is managed is more explicit now. For example, the optimizer update is now optimizer update and giving it the model and gradients. You explicitly pass the model state in. This functional style makes it much easier to reason about what's happening in your training step, as there are fewer hidden side effects to track. Finally, JIT error messages can sometimes be indirect, making tools like checks or temporarily disabling JIT crucial for locating the exact source of a problem. So, to help you work, let's take a look at a recommended debugging workflow. So how should you approach debugging? Well, start with static checks. Look at your model with NNX display, add checks, shape, and type assertions, and if issues arise during runtime inside JIT, your first step for numerical problems should be checking for nans or infinities. Because your model is a PyTree, you can directly use checks.assertTreeAllFinite or assertTreeAllClose on the entire model object inside a checksified function. This is a huge time saver. For other issues, use JAX.debugPrint to inspect values or JAX.debugBreakpoint for interactive debugging. If you're really stuck or the JAX tools aren't cutting it, don't hesitate to temporarily disable JIT and bring in PDB or your favorite IDE debugger. For performance, use AssertMax traces and the JAX profiler. And always have TensorBoard running to monitor your training dynamics. So in the end, debugging JAX and Flax NNX effectively involves understanding the implications of JIT compilation and learning the specialized tools JAX provides, like JAX-debugPrint and JAX-debugBreakpoint. Remember, JAX.disableJIT is your friend for complex issues at the cost of speed. Flax NNX helps with inspection via NNX display, and checks is essential for robust assertions. TensorBoard remains a key part of the workflow. By combining these tools systematically, you can debug your JAX applications efficiently. You can learn more about JAX and the entire JAX AI stack with these coding exercises, quick reference docs, and slides. To watch the whole Learning JAX series, check out our playlist on YouTube. There's a growing community on Discord for JAX, and here's an invite link, and here are links for the docs for JAX, Flax, and the JAX AI stack. There's much more coming up in our upcoming episodes on the rest of the JAX AI stack, so stay tuned, and don't forget to hit like and subscribe, and we'll see you soon.